Hello, everyone. All right, so we're continuing on in our grade 10 lessons on quadratics, right? And we've done basically a lot of graphing. We've looked at a lot of, the features of a parabola and the vertex and how to graph and how to get an equation from a graph. We've kind of skipped so far the sort of algebraic portion of it. And that's what we're going to start looking at now. The first thing we're going to look at is how to actually manipulate these things. And we're gonna we've seen vertex form, and I think in the homework in lesson 8, there's actually one in standard form, and there's also something called factored form. So we're gonna have to be able to manipulate these quadratics algebraically to be able to extract certain information from them. So the first thing we're gonna do is we're gonna look at today multiplying in terms of polynomials. Remember, a polynomial is just anything with a bunch of x's and powers and coefficients. Right? It's basically a sum of x n's, where n can be any number. So let's start off simple, right? When we talk about expanding, the word expanding really means multiplication. So when I have these numbers, or monomials, I should say, multiplying into a binomial, that means there's two terms. So we have this one term here. This is 4. Oh, sorry. I have 4 here. Now, if I want to multiply, I'm going to have to multiply the 4 times everything inside the bracket. So I'm going to have to multiply 4 times x and 4 times 1, which is going to give me 4x plus 4. Okay, so this is the expanded form of 4 multiplied by x plus 1. It gives us 4x plus 4. Same thing for here, the letter B, I have a negative 2 multiplied by 3x minus 4. So same thing. So negative 2 times 3x, that's going to give us negative 6x. And now, careful, negative 2 times negative 4 is going to give us positive 8. Now, this is one of the major mistakes you are going to make. Okay? Just watch your signs. Remember, a negative and a negative make a positive. If the signs are the same, it'll always make it positive. If the two things are multiplied have opposite signs, we end up with a negative, right? So positive and a positive make a positive, positive, negative, 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 positive, negative, 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 make positive. Okay? Just a quick little refresher there. Now, what happens if we're multiplying by 3x? So what is x times x? And that's going to give us 3x squared, right? Because that's going to be x multiplied by itself, which we call x squared. And here now, 3x times negative 7 is going to give us negative 21x. Okay, so that's a monomial times a binomial. Now, what happens if instead we're going to look at a binomial multiplied by a binomial? Now, this is going to have to be a bit more careful, because how many actual products are we making here? How many multiplications are happening when I have two terms and another two terms? Right, because I'm going to have x multiplied by everything inside the bracket, the second brackets, right? And also have 2 times everything in the brackets. Another way we can think about this is think of all the possible products, right? If we have x plus 2 multiplied by x plus 1, we're going to get 4 things inside this sort of grid, right? We're going to have x times x, which is x squared, x times 2, which is 2x, x times 1, which is just x, and then 1 times 1, 1 times 2, which is going to give us 2. So our answer is going to end up being the sum of all these things inside of our grid. Or x squared plus 2x plus x plus 2. Now notice these things here, we call these cross terms. Right? This is the middle part here. And they, in this case, have the same variable in the same power. So these are actually like terms. So we can actually add these two together. So we can actually end up with, a final answer here of x squared plus 3x, right? Because we have two x's and I'm adding another 1x. So 2 plus 1 is 3x plus 2. And that's our final answer. So x plus 2 multiplied by x plus 1 is going to be x squared plus 2, right? So that's the outside. It's these guys here. But then we have this cross term, the one in the middle. That's going to be these inside terms. So that's going to be 2x plus x, which is just 3x. All right? Apologies for all my scribbles making everything messy. So let's try some more examples. Well, sorry. Now, the way to remember this, the way I was taught, and very famous sort of acronym to help us remember this, is when we're multiplying two binomials, we have to multiply the first terms, x times x. Then we're going to multiply the outside terms, the x times the 1. Then we're going to multiply the inside terms, 2 times x. And then we're going to multiply the last terms, the 2 times 1. And this gives us the nice acronym of FOIL. So if ever a math teacher tells you to FOIL something, it's telling you to multiply the binomials, do all the multiplications possible. Okay? So first, outside, inside, last. Do that again. So the first terms, the outside terms, the inside terms, and the last terms. And that will give us all the multiplications. And we add them all together, and we're done. And we make sure we simplify. Right? So one of the things in expanding is after you're done, you have to simplify. Make sure that it's to its lowest terms. All the like terms are all added together. So let's try some examples. So x minus 3 multiplied by x plus 6. So again, we're going to have to do all of our first x times x, 6 times x, negative 3 times x, and negative 3 times 6. When we do that, we end up with x squared negative 3x plus 6x minus 18. Now, the most likely place for you to make mistakes here is with the signs. Okay, so be careful. Negative 3 multiplied by x is negative 3x. And the last thing we're going to have to do is negative 3 plus 6 is going to give us 3x. There's our final answer, and we're done. Okay, so x minus 3 times x plus 6 is actually x squared plus 3x minus 18. Okay, that's a simple one. What about a bit more complicated, where you have a few more coefficients? Now, if the x, or the variable term, also has a coefficient, same thing. So we're going to do 2x times 3x, 2x times negative 8, negative 1 times 3x, and negative 1 times negative 8. Careful again. Negative times negative because it's positive. So what are we going to here? We're going to have 6x squared from the 2x times 3x. 2x multiplied by negative 8 is going to give us negative 16x. Negative 1 times 3x is going to give us negative 3x. And negative 1 times negative 8 is going to give us positive 8. And then we just have to add these two together, and we end up with negative 19. Okay? And that's our final answer. Now, what about if they don't explicitly tell us that they're multiplying two binomials? What if they just square it? X minus 3 all squared, right? That's actually saying x minus 3 times x minus 3. Now, one of the most common mistakes you'll ever see in math is somebody distributing power. Distributing a power, right? When I multiplied 2 times x minus 1, say, I can distribute the multiplication, right? 2 distributes here. Say this is going to be 2x minus 2. Multiplication has the property of being distributive. Now, when I square something, when I take a power, x minus 3 squared, the temptation is to be like, oh, I can just distribute that. This will just be x squared plus 9, right? Done. No. Okay, we have to be very careful here because we're going to have those cross terms. This is not correct. You cannot distribute a power. To do this properly, we have to do our foiling. We have to write it out. X minus 3 multiplied by x minus 3. Because we're going to have those two terms. We're going to have x squared and positive 9. But we're also going to have those two other multiplications happening. So we're really going to end up with x squared minus 3x plus 9, which works out to x squared minus 6x plus 9. Right? So when we did our mistake by distributing, we missed out on what we called the cross term. Okay, that's crucial. You cannot distribute power. Very tempting, like, oh yeah, I can just, no, you can't rainbows a power. What happens if now instead we have a coefficient out in front? Let's just not worry about it for now. Let's just do what we know. We know to do this first, outside, inside, last. Let's do that first. So if we multiply this out, we're going to end up with 2x times x, 2x squared, 2x times negative 5, negative 10x, 3 times x, which is 3x, and 3 times negative 5, which is negative. Notice I kept this, I just rewrote the 4, put brackets around the whole multiplication, and left the 4 there. Now I'm going to take my like terms in the middle here. So negative 10 plus 3 is going to be negative 7. So I've done what I've done before, right? But I still have this 4 out here. So the last thing I have to do is now distribute my 4 into everything. I have to multiply it. Difficult to see. Should have left a bit more room. Sorry about that. I need to now multiply the 4 into everything. That's going to give me 4 times 2, which is 8, x squared. 4 times negative 7, which is negative 28 squared. Negative 28x. And 4 times negative 15, which is negative 60. Okay, so if there's a number in front, we leave that for the last step. Okay, do all your foiling out first, and then distribute your coefficient. Okay. All right. So what about more complicated ones where you have multiple things happening? Uh-oh, that looks scary. It does look scary, but don't be scared. Just one step at a time. So first thing I'm going to do, I notice this square here, right? So let's take that square and rewrite it as x minus 6 times x minus 6. Okay, so then I can do my FOIL. I'm going to multiply out my binomial. And over on this term here, I have negative 2 here multiplied by, it's a subtract. Really, it's say 4 times x minus 6 all squared, subtract 2 times all that. But another way we can think about it is we can say that we are adding negative 2 times 2x plus 3, which is going to make our life simpler if we worry about that negative in there. Because when I multiply this negative 2 into everything, then I'm not going to have to worry about that negative. Okay, so what do I mean by that? So what's going to happen here? I'm going to end up with, again, the 4 just migrates down. I'm going to do my foiling. So x times x, x squared. X times negative 6, negative 6. Negative 6 times x, negative 6x. Negative 6 times negative 6, positive 36. Okay, so that's my foiling of my binomials. My 4 is still there. Now what happened on this side? Because I put brackets around my thing, I don't have to worry about it too much, because the second term, second portion of my problem is just going to be negative 2 times 2x, which is going to give us negative 4x, and negative 2 times positive 3, which is negative 6. So that's going to be just outside. So I'm going to still have this portion here. Because I have brackets, I still have to do the multiplication. So I still have to do BEDMAS, right? Remember what BEDMAS stands for. But I have my 4 that I can now, oh no wait, I'm going to collect like terms. Then multiply my 4 into everything. Now I have no brackets, and now I can collect the x's and the numbers. So I'm going to have still 4x squared. That hasn't changed. But I had negative 48x subtract 4x, which is going to give you a total of negative 52x's. And then I have positive 144, take away 6, which is going to be positive 138. Ew, that was a gross one. Okay, so a whole bunch of steps happen here. This is why I need you to be very careful with your positive and negative signs. One little mistake up at the top will bleed through all the way to the bottom and make your answer wrong. So just be very, very careful. Okay, so when I have an extra piece added here, just treat that negative sign as a negative, sorry, the subtraction here as an adding negative 2. So then my negative can distribute into the bracket, and it'll end up with that extra term being there. Okay. All right. What about a binomial times a trinomial? Okay, can we FOIL this? We have to do more than FOIL. Remember, when we're multiplying something like this, we have to multiply, do all the multiplications possible. So the way I like to worry about it is I take my first term here, so let's say 2x. I'm going to multiply 2x into everything in my second bracket. Okay, so there's 3 multiplications already. So just from the 2x, that multiplies into all 3 terms in the second bracket. Then my negative 2 is going to multiply by everything as well. So we're going to end up with actually 6 multiplications happening. There's no nice acronym here. What would be first, middle, I don't know, silly. But it's going to give us 6 things. So let's see what happens. How did I get this? 2x times x squared. That's going to give me 2x cubed. Okay, so remember your x is just x to the 1, x squared. If I'm multiplying powers and they have the same base, we're going to end up with x. What's 1 plus 2? It's 3. Okay, so 2x times x squared is going to actually be x cubed. So 2x cubed. And then the next term is going to be 2x multiplied by 3x. 2 times 3 is 6. X times x is x squared. And then 2x times negative 4 is going to give me negative 8x. So these 3 terms came from multiplying the whole second bracket by 2x. Then these 3 terms are going to come from the negative 2. So it's going to be negative 2 times x, so it's going to be negative 2x squared. Negative 2 times 3x, negative 6x. And negative 2 times negative 4, positive 8. Okay, careful again with the positive. And now, since we have it all written out in this expanded form, you can see that we have 6x squared, and we have negative 2x squared. Then I also have negative 8x, negative 6x. So I can collect those like terms, which gives us a final answer of 2x cubed, because that was the only cubic term. Then we have 6 take away 2, which is 4. And then negative 8 take away 6, which is negative 14. And then there was the only numerical term was 8. The 8 just went down there. 2x cubed went there. Okay, so multiplying by a binomial, in this case here, this is a binomial, times a trinomial, the same idea. It's just we're going to have 6 multiplications instead. Okay, now what happens if we have 3 binomials? X minus 4 cubed. That's going to be x minus 4 times x minus 4 times x minus 4. How am I going to tackle this? I'm going to break it apart. I'm only going to worry about the second and the third bracket first. I'm going to look at this FOIL. Right, so x times x, x squared. X times negative 4, x times negative 4 gives me negative 8. I skipped a step there because I'm going to run out of room. But really, we should get the outside inside is going to be 2 negative 4x's. Right, there's going to be negative 4x and negative 4x, which is going to give us negative 8x, which is what I have here. All right, and then negative 4 times negative 4 is positive 16. So this trinomial here is what I got from the expanding of the second and third bracket. I still have my first bracket, and I still have my x minus 4, so I have to do, again, with the trinomial. So to multiply x into everything, and then negative 4 into everything. That's going to give me a nice 6 terms here. So x times x squared is x cubed. X times negative 8 is negative 8x squared. X times 16 is 16x. Right, so these three terms again is just my second bracket. Everything in my second bracket multiplied by x. Notice it looks the same as my second bracket, but these now x cubed, x squared, x. Then I'm going to multiply negative 4, so that's going to give me negative 4x squared. Negative 4 times negative 4 is negative 32, and negative 4 times 16 is negative 64. And again, I have my like terms to give me a final answer of x cubed minus 12x squared minus 24x minus 64. All right, so that's how you expand three binomials. We just do the one binomial, and then we multiply the 6 multiplications for the third binomial. And then, again, at the end of everything, we always simplify. What about two trinomials? Can we multiply a trinomial times a trinomial? How many multiplications are going to be here? Now let's do this a little bit more color-coded. So this first trinomial is x squared minus 2x plus 1. So I'm going to have to multiply x squared times everything in my bracket here. I have 3 multiplications from my x squared. Then I'm going to have 3 more multiplications from my negative 2x, because negative 2x is going to multiply everything into there. And then my negative 1 is going to go into there as well. So there's going to be 9 terms. You can think about it. There's going to be x squared minus 2 plus 1, x squared 6 plus 5. How many multiplications are there? There's going to be 9. Right? There's 9 terms that are going to be multiplied. All right? There's going to be 9 things in there. If I color code them here, I'm going to get rid of all those rainbows because that looks scary. So if I color code them all, what am I going to get? I'm going to get x squared times everything in the second bracket. So that's going to raise the power of everything in the second bracket by 2. So that's going to be x to the power 4, 6x cubed, negative 6x cubed, and 5x squared. Notice I've just raised the power of everything times 2. Okay? So now let's do all our blue multiplications. That's going to be negative 2x times everything in the bracket. Right? So negative 2x times x squared. Oops, sorry. So that's going to be negative 2x cubed, right? Because we're going to raise the power of this by 1. Negative 2 times negative 6. It's going to give us positive 12. X times x squared. Negative 2 times positive 5. That's going to be negative 10. And then we just have an x. So that's all of our everything in the second bracket multiplied by negative 2x. And then last but not least, everything times 1, which is just rewriting the bracket again, right? 1 times x squared is x squared. 1 times negative 6x is 6x. 1 times 5 is 5. All right, so we end up with 9 terms, which we have to simplify. So what do we have here? We have negative 6x cubed. Any other cubes? Oh, there's one there. What about squares? I have 5x squared, sorry, 12x squared, and another 1 here. And then I have negative 10x's and negative 6x's. So when I simplify that, what am I going to get? I'm going to get x to the power of 4. This is only 1. Then negative 6 negative 6, subtract 2, negative 8, and then 5 plus 12 plus 1, remember there's a 1, hidden 1 there, is 18, and negative 10, take away 6 is negative 16, and then just the 5 by itself. So we end up with a 5-nomial, a 5th order polynomial, you could say, or a 4th degree polynomial. Degree is the highest power. You could say this is 5th order. Yeah, whatever. It's a polynomial. It's a big term. It's a quartic. There's a good word for you. Quartic. If it's x squared, this is called a quadratic. It's x cubed is a cubic. So a quadratic is x squared term. Cubic has the highest power of x cubed, and a quartic has the highest power of x to the 4. I don't think there's any name for 5th pentic, maybe. I've never heard that before. Anyways, all right. So there's a whole bunch of examples. If you want to watch them, go back in the video and watch them again. The assignment, I think, has 10 problems, which are very similar to these ones. So just work. So there's no graphing or anything in this in lesson 9's assignment. It's just a bunch of algebra. Okay, so on a separate sheet of paper, show all your work. Okay, carefully. Make sure you watch your signs. Make sure you write out all your multiplications, just like I did in all these examples here. Okay, so make sure you show all your work, or else you're going to make mistakes. All right, and just be careful with your signs. Any questions, just reach out to me, and all the best. Hope you guys are doing awesome, and I'll be talking to you later.